The question we are solving now belongs to test series 3. It is of control system subject. In specific, it belongs to time response analysis of control systems. As per the question, there is a control system which is as shown in the figure. The control system contains a forward path system of transfer function 10 divided by s into s plus 1, and it has mainly two feedback paths. The feedback path 1 has a transfer function of s divided by 10, and the feedback path 2 has a unit transfer function of 1. It means that the feedback path 2 is a unity negative feedback. We need to find the instant at which the second undershoot occurs. So for finding the instant of the second undershoot, let us find the overall transfer function of the control system, for which we will find the transfer function of the control system that is marked. It is given as T1 of s is equal to g of s divided by 1 plus g of s into h of s. Please note that here g of s is equal to 10 by s into s plus 1, and h of s is equal to s by 10. So upon substituting the quantities, we see that the transfer function of the control system marked gets simplified as 10 divided by s square plus 2s. Now let us find the control system. Let us find the transfer function of the overall control system, which is written as T of s is equal to T1 of s divided by 1 plus T1 of s. This is equal to 10 divided by s square plus 2s as a whole divided by 1 plus 10 divided by s square plus 2s. Please note that here the feedback is unity negative feedback. So the overall transfer function gets simplified as 10 divided by s square plus 2s plus 10. So from the given data, from the obtained transfer function, we see that the characteristic equation of the control system is s square plus 2s plus 10 is equal to 0. So here the natural frequency of the oscillation of the control system is omega n is equal to root 10 radians per second. This is mainly obtained by comparing the characteristic equation with the standard characteristic equation s square plus 2 eta omega n s plus omega n square is equal to 0. And also we know that from the standard form 2 eta omega n is equal to 2, that implies eta is equal to 1 by root 10. As eta is less than 1, we can say that in the unit step response of the control system, there will be undershoots and overshoots. So the instant of the second undershoot can be given as TPU2 is equal to 4 pi divided by omega n multiplied by square root of 1 minus eta square, which can be simplified as 4 pi divided by root 10 multiplied by square root of 1 minus 1 by 10, that is equal to 4 pi by 3. So from this we see that for the given control system, the second undershoot occurs at 4 pi by 3 second. Please note that the second undershoot occurs for you at this instant for unit impulse input and unit step input. Hence, the correct option representing the second undershoot time is 4 pi by 3 second, and it corresponds to the option A.